Yeah. Hey, okay, welcome everybody. We're here for our first online lab, and I will begin by saying grab your lab manual and turn to page 60. This is the lab that is the specific heat. Let me hold up the front page up here, right here. Here's specific heat. And maybe more important is to go to page 62. Page 62 is where we're going to start writing in our data. All right, so I will begin way over here on this part of the board here, where I hope to remind you of what you learned in class, and that is, what is the specific heat? All right, so the specific heat is defined this way. It is the amount of energy needed to raise 1 gram 1 degree Celsius. So every material will have a different specific heat. So our goal here today is, and here's your equipment, is we are going to try to measure then what is the specific heat of brass, what is the specific heat of aluminum, and what is the specific heat of lead. And so those are our 3 main pieces. And we're going to fill it in this chart on page 62. Now, let me change these words into an equation. All right, so here's your equation. The symbol that you've learned for specific heat is the symbol C. The symbol for heat is Q. And then per gram, so I'll put M for mass, and delta T. This equation, of course, becomes Q equals MC delta T. And so that's kind of my review here that I think you already saw in class. And so if we have a particular material, and again, I'll just come over here and show you. Here's this brass piece. This is going to be one of the first ones we do. If this brass piece would warm up or cool down, in our case we're going to cool it down by some change in temperature, then when I multiply these 3 together, this would tell me how much heat comes out of this piece of brass. Because if I could draw a picture before I show you the equipment, it would look like this. You're going to take a hot piece of metal, and you're going to put it into a little styrofoam cup that has some cool water. And the idea here is the heat energy will come out of the metal, so the metal is going to cool down. And then as you put it in this water, the water temperature is going to go up. And so we would say something like this: because of conservation of energy, the heat that comes out of the metal is then equal to the heat that goes into the cool water. And so that's the whole idea behind this equipment that we're going to do here in just a second. So mathematically, it would look this way. If we're talking about the metal, and we come back here to this equation, this would be MC delta T, and this would all be for the metal. That would have to equal then the MC delta T for the cool water. Now, a little subtlety here is, since I'm talking in absolute values, let me just make sure that I put absolute value here, because usually when you calculate a temperature difference, you go final minus initial, and that's fine. We just don't want any negative numbers here, okay? And so the energy out of the hot metal goes into the cold water. Your job, and this is the whole purpose of today's lab, is to find this. What is the specific heat of your metal? That's your goal. So in order to do that, you're going to need to measure these other pieces. And so this piece here, which is going to be the mass of the metal, will be the first thing that I will measure with you together. Another thing, of course, we need to measure is this change in temperature of the metal. More on that in just a second. Of course, the other thing we need is the mass of our, I guess this would be our water here. We'll need to know the specific heat of our water. More on that in just a second. And then finally, the change in temperature of our water. We'll need that one too. But I'll begin here. Let's focus on this for just a second. And so if I grab your little worksheet here, you'll see that in the very top row, it says, what metal do you have? And here's what we're going to do in this order. We're going to do brass, then we're going to do aluminum, and then we're going to do lead. Okay? So, right across there, brass, aluminum, and lead. Because if you then look, the two rows below that are the mass of the water and the mass of the metal. Let me start with the easier of the two. It's the third row down, but it's this one here. It's what is the mass of the metal. Since that's an easy one to get, let's write those all down together. Okay? Come with me over here to the scale. And I will start with brass. Let me just zero the scale. Okay? And so write down the brass. Here is the mass of the brass. 269.7 grams. Write down the mass of the aluminum. All right? So we're working as a team here. So aluminum has a mass of 91.6 grams. Okay. And then finally our third metal for today, the lead one. And the lead is a heavier 354.7 grams. All right. So that's part of our data. Now, the other part of the data, as we said, is this one here. What is the mass of our water? All right. So putting those in the same order, I'm going to go ahead and put the brass in here, and to set things up, I'm going to put the brass in some boiling water. Then I'll put the aluminum in some boiling water, and I'm going to put the lead in some boiling water. And so while we're getting the rest of our data, all of that can be warming up. All right, so back to here. Let's get the mass of the water for the brass one. So coming back over to the scale, let me point out that the cup itself is already 2.1 grams. So when I pour this in here, and I'm going to get myself about an inch of water. That'll be enough to cover it. Don't forget to subtract off 2.1 grams for the cup. So right now, the water for the brass experiment is 73.7 grams. Okay? So write that number down. He'll be our second one. Here's our aluminum. Okay. And so let me put the cup on here again. Now this cup is 2.2 grams, so it's a hair higher, 2.2 grams. And let me just pour in a little bit of water. That looks like it'll be enough to cover it when I put it over. Okay, and here I have 72.1 grams. So not close to the same, but not exactly. And so this will be our third and final experiment. And I'll put the cup on here first. And this cup is 2.1 grams. Oh, I just toggled up. How about 2.2 grams? All right. And then same idea. I'm going to put a little bit of water in here. What I think is enough to probably cover it. All right. And this happens to be 73.4 grams. Okay, so we've got the first stuff, what I'll call the easy stuff here, where I've got these two. I've got the mass of each of the metals, and I've got the mass of the amount of water that I'm going to put them in each step. Okay, now let me keep going with this. And so I'll put here mass of the metal, so I'll leave that one alone. Here is the specific heat of the metal. Now remember, this is what we're after. Let's talk about the change in temperature of the metal. You see, what's going to happen here is I'm going to take this piece of metal out of the boiling water, so it's 100 degrees, and then I'm going to put it in the cool water. I'm going to mix it around and find its final temperature. But here's what that tells me. That tells me that its starting temperature is 100 degrees. And so I will measure the final temperature. So this is the final temperature when I eventually mix them. Now, the other side of the equation, over here, the mass of the water. Okay, we hopefully already have that. And let me just give you, especially in case if you forgot it from class, the specific heat for water is the 1 calorie per gram for each degree Celsius. So I'm just going to give that to you. That's taken as you know what that one is. And then the same idea here is we've got to get the change in temperature. And so in this case, the water is going to warm it up. So I'm going to put final temperature minus initial. And the initial will be the initial temperature of our water. And let's see what that is. And let's see if they're different. I hope they're not. It'll be easier if they're all the same starting temperature. And so as I put the thermometer in here, I get 19.8. Here I get 19.8. And the third one, I get 19.8. Okay, so good. I can have all of these at a starting temperature of 19.8 degrees Celsius. And so you can now see that the main part of this experiment is to mix them together and find their final temperature. And once you have the final temperature, we can then plug it into here together with the mass of the water in each of those individual cases, together with the mass of the metal in the individual cases, and you can find the specific heat. And so it's this chart that I hope you are filling in, and you're eventually going to answer this question right here. What is the specific heat? All right, so here's where the fun begins. So let me take and maybe give myself a little bit of working room. I'll move these out of the way and say, all right, I'm going to take my digital thermometer and I'm going to put it in my container. I'm going to grab my metal block and just dunk it all the way under the water for a second to make sure it's good and underneath. I'm going to get them as close as I can so I hopefully don't lose any heat. And I will tell you, We tend to get some low values. I think it's because of the loss of heat along the way. So let's just see how close we do get and keep our fingers crossed for some good numbers. And go. And so then I will just casually stir and watch the temperature go up. We are already at 35 degrees, but don't write that down. Let's just keep going here. Oops, I dropped my thermometer. And maybe for an added help here, maybe I'll make sure it's good and stirred, but I think just kind of swashing it works a little bit better. That's what I've done in the past. And it looks like we're coming to the end of this first one. I've got 39.0, and I think we are done. Oh, 39.1, it went up. So 39.2, I take that back. Okay, and this is the brass. Yeah, so I'm hoping. All right. So let's call this final temperature for the brass 39.2. And let's try it again for the aluminum. So coming back over here to my aluminum and dunking the aluminum down here and saying, all right, here we go. 1, 2, 3, go. Oh, I spilled a little bit. Hopefully that'll still be okay. But let's watch its temperature go up. And so we're at 24, 25, 26, 27, 28, 29, 30, 32. And it's still going up. 36. 36.2, 36.3, 36, 36.4. And 36.4, looks like this might be the end. 36.4. All right, well, I'm going to call it 36.4 and let's see how our numbers work out. And then we will move on to our third and final experiment here for today and our first online lab. And now I drop the whole thing in the bottom. But I think I can still grab it. Okay, here we go. 1, 2, 3. And I'm going to warm it up again now that I dropped it. All right. Give it just a second there. And we're going to try this all again. Okay, 1, 2, 3, go. And dunk it in. And just like the other two, let's watch what happens. All right, so where are we now? So we're at 27.5 right now, going up. 29.1, 29.2, 29.3, 29.4, 29.5, 29.6. And we're still at 29.6. 29.7. 29.7. And let's call it good. 29.7. All right, well, that'll be the end of this part. Now you've got to do the calculations, and I'll send you a second email or video about some discussion with the questions.